Everyone. I thought it'd be good to go over when do you use which strategy to find the missing sides of a triangle. Because right now you've been introduced to using the Pythagorean theorem, you've used trigonometry ratios, you've used special right triangle ratios, and of course there's equilateral triangles and isosceles triangles. Unless you have an isosceles triangle or an equilateral triangle, you will need a right triangle. That's the first thing to look for. There are three different strategies and situations. You are given a right triangle and any two sides. That's the first situation. So again, you notice the two right triangles, and each of them, you're given two different sides. Notice there's no angles. There could be angles, but that doesn't matter. But the fact that you have two sides means right away you can use the Pythagorean theorem. So here I've done out the solutions to both, two different situations. One, you're looking for the hypotenuse. The other, you're given the hypotenuse, but you're looking for one of the legs. So a slightly different algebraic situation, but you can still get your answers noted below. You'll notice on the left, it's a square root of 165 equals x because that is an exact answer. Because the square root of 165 is irrational. Over here, I did not use the square root symbol, but you'll notice I said y is approximately equal to 2.96. Another situation is when you're given a right triangle, but this time you're given one angle and one side length. So notice again, there's only one side length given in both of these situations, but you're given either a 30, 60, or 45-degree angle, indicating that you're going to use your special right triangle ratios, or the fact that you know this triangle right here is an isosceles triangle. So you have two sides that are equal, so that can help you out. And then you can use the Pythagorean theorem. Or you know that over here, this triangle is half of an equilateral triangle. So if you wanted to, you notice the 60-degree angle, you could continue to draw the other part of the equilateral triangle. Therefore, you know this whole side is 5 centimeters. That gives you the short leg, which now you know would be 2.5. Then you can use the Pythagorean theorem. Or again, like I said, you can use your ratios that you just learned about. And here I've done it out. In this case, you can use the Pythagorean theorem or use your ratios. Same thing with this one. You've got your short leg. The short leg is always going to be half of the hypotenuse. And then the long leg, you can either use the Pythagorean theorem, or we always know that the long leg is going to be whatever the length the short leg is times the square root of 3. Our third situation and final situation today is, again, when you're given a right triangle, you're given one angle, but this time it can be any degree and one side length. So in this case, because your angle degrees are not your special right triangles and you're not given two sides, you would have to use trig. So you can use sine, cosine, or tangent, which it just depends on which side you're looking for, which side you're given, according to the reference angle. So I've done this out. I know that we learned trig most recently. So in this case, if you look at this example, your reference angle is 26 degrees. You look at the side opposite, that's your x, and you're given the hypotenuse. Don't worry about this side at all. You're not interested in it because you only want to deal with two sides at a time. So if you think back on your SOHCAHTOA, sine is equal to the opposite divided by the hypotenuse. So in that case, you'll use sine, and this is always how you'll set up your ratio. The opposite is always going to be divided by the hypotenuse in this situation. So you use your calculator to find out what the sine of 26 degrees is. Now it's just algebra. Multiply both sides by 12, and you get that x is approximately equal to 5.26. In the next example, this is the same situation. Notice you're only given one angle, and it's not one of your special right triangles. You're only given one side, so you can't use the Pythagorean theorem. So you have to use your trig ratios. So at this point, if you look here, you'll notice that your opposite side is what you're looking for, and you're given the adjacent side. Notice that the hypotenuse is not involved at all, so you would not want to use sine or cosine. Tangent is the only one that does not involve the hypotenuse. So you set up your equation, again using your calculator or your trig table to find out what the tangent ratio of 40 degrees is, and then you solve for k. The last thing I wanted to go over, I'm really big into verifying your answer. You really should always check to make sure your answer makes sense. You're going to make mistakes, that's just how it is. And so this helps you realize when you've made a mistake. So in this case, we found that x was equal to square root of 164. Well, that doesn't mean a whole lot, except for you do notice that x is the hypotenuse, so it better be more than your other two legs. And right away, you know the square root of 164 is going to be more than 10, and it's approximately 12.8. So that at least gives you a good sense for, okay, that makes sense. In this example, x is 5, and that should make sense because you do indeed have an isosceles triangle. And y is 5 times whatever the square root of 2 is. The square root of 2 is approximately 1.4. So it's should be a little bit more than 5, but less than 10, right? Because it's 1.4, it's not twice the amount. So again, that's in the ballpark. You know at least your hypotenuse is longer than your other two legs. In this situation, this is a really big idea where we talk about short leg and long leg. The short leg, if you think about it, the angle that's created with these two rays creates a side across from it that's going to be smaller than the angle formed by the 60-degree angle. So W is considered the short leg, P is considered the long leg, and your hypotenuse still stays the same. It's consistent with a right triangle. Does it make sense that your short leg is 2.5? Yeah, because it should be half of the hypotenuse. But then more importantly, comparing the short leg and the long leg, you can see that the long leg is indeed longer than the short leg. And if you were to multiply 2.5 times the square root of 3, the square root of 3 is about 1.7, so less than 2. So if it's less than 2, that means 2.5 times the square root of 3 has to be less than 5. So you're okay there as well. Because again, the hypotenuse should be the longest side. In this example, we know that your reference angle is 26 degrees. So that, again, it's got to be smaller than the hypotenuse. If you really wanted to check, you could find your other angle by subtracting from 180 degrees and find that side length, which should be longer than 5.26. And again, I always like to say it's kind of in the ballpark of that 12 centimeters. You notice you didn't get 52.6, which might be an error. And then lastly, the last one, 40 degrees. I think this one's really interesting because if you know that your reference angle is 40 degrees, the other one is going to be 50 degrees. Those two are pretty close numerically. So doesn't it make sense that your two answers are pretty close, but yet the side across from the 40 degrees is smaller than the side 3, which would be across from the 50 degrees. So again, it gives you that sense. Notice that it's kind of close to being 45, 45. Notice again that the numbers are pretty close numerically. So anyway, it's always important to verify your answer when you do this, just to make sure that you didn't make any mistakes.